So the next thing to show is how we handle method calls inside the sequence diagram. For example, simulation scenario class that we used in our discussion about abstract factory design pattern has method name create visitors. So we want to show that our main function calls this method. So we can do it like this, and once again I immediately add blank return display instead of void, which is shown as a default in the diagramming tool. So here we just have this method call like this, and of course this call goes into this simulation scenario, which has been already created by our constructor, and now create visitors is actually also using empty parentheses here. We can maybe add a space here for just for display purposes. And now you can see that this is the next method call that happens inside our main method. So you can see that the call going to the simulation scenario object, and it's very important to understand who is doing what. First of all, this operation create visitors belongs to the simulation scenario class, right? So this is an object of this class, and so this operation create visitors here belongs to this class. And it is visible in our script very nicely in the diagram itself. You should always remember that the operation belongs to the object to which the arrow is pointing. So here's the arrow that we can see in the diagram, and we have this operation pointing here, and this is the name of the operation. So this operation is available inside this class, and it belongs to this class. So the next thing to discuss, that we know that create visitor method invokes factory interface with create visitor method, which creates a new visitor object. So that's something that we already tried to demonstrate in our previous video. So how would we show this? So step number one, we replace the semicolon of this method because we want to expand what's happening inside. So we replace the semicolon with a set of brackets like this. And let me just keep this diagram up to date right here with my script like this. And you can see that basically nothing really changes in the appearance of the diagram itself. Right? Not yet. However, it gives us place right here. So inside this set of brackets gives us place to show further actions inside the brackets right here. And this time it's happening inside the operation that belongs to the simulation scenario object. So let's add a call into factory object and subsequently a call into constructor of the visitor object that the factory creates. So we can do it like this maybe. I'll just make some adjustments, and I can just copy the entire new version of this script right here. It's easier for me to do it like this. So now this is really good. We can see that now the entire set of the steps that we can describe in our use case scenario, and in addition we see all of our objects across the top of the diagram. Okay, so we have the main method where execution begins, we have creation of a factory, we have simulation scenario creation, then we have a call into create visitor, and now we have more details about what's happening inside that create visitor method. Specifically, the simulation scenario makes a call into create visitor inside this object, which in turn calls, so inside this factory visitor shopper create visitor operation, we call new and create visitor shopper. Okay, so this is a new object that we create as part of this display of these individual steps. And once it's complete, the constructor of this object is complete, so we have now a new object in view. And now we just return, and we return, and we return back to main function in case of C++, or main method in case of Java. So these objects across the top are formally known as participants in the sequence diagram. So let's talk about sequence diagram options for the participants. So participant names are specified in format name: class, where both name of the object, so this is the name of the object, and its type, like class, can be shown, but both are optional. So we can display class, we can display just the name, or we can display the combination of both. So you must skip the colon if using the class name. And in UML version 2, objects are shown without the underline. The original requirement was that the underline is shown whenever we use objects. So activation bars are optional UML, but extremely valuable in clarifying the behavior. So what diagramming options are available for these participants in Alex Moffat's sequence tool? So, well, the names of classes can be also converted to strings inside the script, like double-quoted strings. So let's try this with one of our objects. For instance, just pick this object, factory visitor shopper, and use quotes for its name. Okay, so this is the change that I'd like to make. Just use quotes right here. And so you can see once again, once the quotes are being specified, however, the diagram really did not change anything in its appearance. So it's just something that really hasn't changed anything. However, now we have a space to customize the display of the participant. So we have our participant right here, and we can customize its display like this. So for instance, we can give this object a name. Okay, so we just add this part right here, just like in our handout, so we can further customize it. You can see that now we have the name of the object, we have the column, and we have the type of the object. So now we specify that this is the class name of the object, and this is the actual object name that we are using. So does this change here really help in terms of making this diagram more readable? Well, quite frankly, not all the time. This is the official UML talk, but in practice, everybody who is reading the diagram should understand that this is not a class diagram. This is an interaction between objects that exist in computer memory. So this is not a class diagram like the one that describes the structure of all classes, right? This is much more dynamic form of a diagram, and it shows the interaction between objects that exist in computer memory. So this is definitely not classes. The participants at the top are objects. So I think any complication in notation in parts of the diagram isn't really an instant benefit in practice. In fact, one of the weaknesses of the sequence diagrams is that if you have like a dozen of object participants across the top, right, it becomes really hard to follow on screen, since you would have to scroll. Like this could really get like much longer horizontally. All right, so it's hard to follow because you would have to scroll the diagram horizontally or make it really low zoom level and very, very difficult to read anyways. So my take is to simply show the class names as participants, ignoring the formal UML rules. Notice that also the latest change here in this diagram. So we just added this. I mean, first of all, we added the quotes, and we of course added the name of the object. So we made the factory visitor shopper actually named object right here in the diagram. So, but this change actually has made it incorrect because we're still calling this factory visitor shopper the old way without the object name. Suddenly it appears as a separate participant right here. So to be consistent, we actually have to make sure that in our script we maintain consistency of references to all of these objects that we use, all of the participants. So just simply copy and paste this new version into this script, and you can see now that we are back to using this, and now the simulation scenario create visitors actually calls create visitor. So this is now appropriately showing the direction of the call create visitor into the correct operation inside this factory.